Okay, so again, because this probably would have been after a few days, then we would revisit what complete the square was. Whenever we do these word problems, first of all, many of them are going to be about like height and profit, so they might have weird a values. They're probably not going to be an a value of 1, okay? So even this one here with the negative, you still have to do like divide by -1. Even that counts as an a value of, that's not 1. Okay, so now we have what our b is. Same thing, half b squared. Add and subtract the number, but also multiply. And then keep that c value. Sorry, I have to sneak it in. If you like arrows, then we're going to that's why we distribute this. You can draw in the distribution arrow. We also, in the other note, drew like an underneath line to show what we're going to factor. So we want, oops. We want the x squared term, x, and the number, right, the trinomial. And our factor is going to be the b value divided by 2. Or you can go through and figure it out, but you don't have to. Negative 36 times 1, -1, sorry, is positive 36 minus 17. So when we do the word problems today, the word problems are going to say, what is the minimum amount? What is the maximum amount? We're always looking at what is the maximum value or the minimum value. So you're going to complete the square to get the vertex. So again, technically in this question, you don't need, it's not asking you to write the vertex out. However, if you're more successful with that, then do that. So we have -6 and positive 19. So same thing with is it a max or a min? If it helps you, this is a negative value, so that means opens down. So then it's a maximum. So the maximum value of y is 19, and when x is -6. So today, when we do the word problems, the y value will be area or profit or height. So the question will say, what is the maximum height of whatever? And so you're looking at the y value, and then the x value of the vertex will be time, or the number of units sold. So I forget who asked me. Somebody asked me yesterday, you guys were working on word problems, and then it was like part A, do this, part B, do this. And then a bunch, if you look at the homework, a bunch of the questions are just like C or D, because the last step or the last question said, what is the maximum height? What is the minimized area or whatever. So that's what we're going to be doing today. So we needed to be able to complete the square and get vertex form in order to completely do the question. So it's a weird list of homework questions because we're just going to go back and do all those maximize and minimize parts, okay? So now here, this one is a 6. -4 is fine. Do -4 divided by 2. And the -4, you have to multiply by 6. So now we have an up parabola, so that means it's a minimum value of y is 41 and x is +2. So you'll start to get to know the problems too, because let's say it's profit, and the question's like, what's the maximum profit and how many units have to be sold to get the maximum profit? If you get a number when you solve for x, if it's negative, then that doesn't make any sense. They sell -2 to make a maximum profit. That obviously doesn't work. Same thing with time. Should you get a time that's negative? No, right? So you can kind of think if your answer makes logical sense. When you're using the vertex to discuss whether it's the situation is maximized or minimized, we call that the optimal value. Oops, there's 2 blanks. When is the situation optimized? And if you think about it, it makes a lot of sense. There are plenty of cases where a business wants to know what is the optimal value. If you have something you're trying to describe its motion, what's its maximum height. If you're building a fence, what's the minimum amount of area we can make or whatever. Okay, so there are plenty of optimization problems. And again, you're going to see this kind of idea even in AP Calculus. They look at a different way to optimize problems. Because math, you want to think about the practical applications as well. Okay, so because I think we are all wanting to make sure that we have the optimized amount of problems to solve, I'm going to focus on some of the problems in this booklet. If you want, I'll post a filled-in note and you can get the other ones. But they're in this textbook, there's no homework questions with, like, for example, the first one about maximizing the number or product. So we won't do that one. Okay, so we won't do this one. And also, I'm going to be nice on the test and the exam. You should write let statements. Usually, students have to write their own quadratic equations, but on the test and the exam, I'm going to give you the equation. So you just have to complete the square to find the maximum, minimum, or optimal value. You have to make sure you answer the question, so we'll look at what that means and make sure you have a therefore statement, okay? So one of the types of problems is talking about maximizing area. So let's say it didn't tell you to complete the square to answer the word problem. You would know that you need to find vertex form because of this word here. Maximize or minimize, you need to find the optimal value of the parabola. And what's the optimal value related to? The vertex. So similar to other types of word problems, which sometimes give people headaches, right? Go right to the end, the last sentence. We want to maximize the area. So this question, let's make our own formula, okay? So I'll show you how it works. So if we're going to maximize the area, then we're going to use area as the y value. And because you're used to the area formula, it's kind of up to you. If you'd rather use x's and y's, you can. Or you're used to what area is, like area is length times width, if it's a rectangle like this, for example. So maybe you want to leave it as a's and L and W, okay? But you can decide. Sometimes you have to draw your own picture, sometimes you don't. So this one, we will. So Geo is building a fence around the beach, okay? So let's say we have a beach. Those are my waves, okay? So he's going to build a fence around the beach. He has 1,600 meters of fencing. It'll only have 3 sides, so we're not going to fence the water, which makes sense. What should the dimensions of the fence be if he wants to maximize the area, okay? It could be a rectangle, it could be a square. We don't know, and it doesn't matter. So it tells you it only has 3 sides, but it's also logical. You're not going to put a fence in front of the water, right, on a beach. So we're also given 1,600. 1,600, is it the area? No, what is it? Perimeter. Okay, so we are going to use that information to help us write our area formula. So when you have perimeter norm of a rectangle, normally you would do 2 lengths and 2 widths, but we only have 1 length. But we still don't have area, and we still don't have a quadratic equation, right? There's no squared term. So we have a few more steps to do. So now we are going to do area, which is length times width. That's what we want. We want to maximize the area. But when you have 2 variables, that can be difficult to solve. But you guys learned a tactic way back in the beginning to get rid of one of the variables. So this has no number in front of it. So what you would have done way back in the beginning, we would have called this equation 1. You would have substituted, moved this over, and then put this into this one. I encouraged you to solve for L because there was no number out front. You can do W too, it doesn't matter, but then you would have to divide everything by 2. So it's up to you. So now we have length in terms of width, and then you had to do this. So this is good review for the exam. Way back to Unit 1 where you had to do stuff like this. This. I just wrote it in brackets. Does that bug you? No problem. Now, sometimes when we give you a word problem, the equation is not going to be perfectly ax squared plus bx plus c equals 0. While that doesn't really matter, what I recommend you do is rearrange it, like just move them around. You're not going to actually have to bring anything to the other side or anything like that. But in this case here, if we were going to distribute this w or this way, it doesn't really matter, then it's going to make the squared term on the end, and most students don't like that. So 1600 times w is 1600w. Negative 2w times w I know there are some of you that don't like it when it's not x's and y's. That's fine. But then make sure you would have to write So if you are going to do that, then you can do that. Just make sure you tell me what your numbers mean, okay? So again, this is sort of ugly. This is not really the form we've used. So I'm going to rearrange it. But I don't have to change the signs or anything. I'm just going to write it. I'm going to put this first, so negative 2w squared plus 1600w. So now the squared term is first, and the non-squared term is second. Okay, so this is A and this is B. That's all I've done. And now it looks like what we've done. You can complete the square. Many of the word problems will not have a little c value, an extra c value. So you actually have maybe even less steps, like maybe you won't have to collect like terms. Okay, so now we have A and B. Oh, not yet. First we have to common factor. So I'm just going to write CF, okay? And now we have B. So yes, that is a big, ugly number, but that's okay, all right? So when you do these maximum profits, it makes sense that the number is large, that you're trying to make lots of money, maximum area, etc., okay? I don't want to squish. I'm just going to move this. You have to do the same thing like we did. You can't forget to times -2. Yes. If you were going to change this to X's and Y's, if you don't want to use A's and W's, which is fine, then make sure you have let statements. If you use W and A, that's okay. Then I'll know what you mean. So if you're not going to, you don't even need to write this down, really. Okay, so here's the kicker with these problems. Have we even answered the question? No. So you need to make sure that you are thinking about what this means. So we would use this to get the optimal value. So what do you think the maximum area is? Good. That's the Y value, right? And then the dimensions are, the width is going to be 400, okay? So this is where maybe it might help you to think in terms of X's and Y's instead. It's really up to you. But when you have the parabola, right, the area and the X is the horizontal, so it is a down. So wherever it is, this maximum optimal value, what do we call that? Vertex? Is this vertex form? Yes. So when is this optimal value here? 3,200 when the width is 400. Okay? So it's up to you. Do you write out the vertex if you want? But even that doesn't really answer this question. So you can think of like, think of this in your little thought bubble, but then you have to make sure your answer statement answers the question, okay? So I'm don't want to squish anymore. I'm going to write over here. So it asks us, what are the dimensions of the fence? So what's the width or the W? Good. We should use, what is it, meters? Yes. And now you have two options. We have this perimeter formula to find the length. You can use that one. But this is simple, right? So most people will choose this one. But it really doesn't matter what you choose to do, okay? Or you could even do, if you do this one, it's already solved for length. If the question says, what is the maximum area? That's where you would say, therefore the maximum area is 3,200,000 meters squared, okay? But it doesn't say that, so technically you don't have to include that in your answer. Okay, this question is more like what you're used to. Again, there's no C value here. So Greg shot a t-shirt out of a t-shirt launcher. The trajectory of the t-shirt can be modeled by the equation h equals negative 5t squared plus 50t. So again, no C value. So A, I sort of left in here because it gave people some trouble. What height did the t-shirt start at? How could I find that? Oops. Or logically, what do you think it is? Where does it start? Kylie? 0. Okay, so the C value is 0, and that's the start value. Or if it's starting, what's time? 0, yeah. I would accept either of those answers. So this is more likely what you are going to have to do. Okay, so you're given the formula. It says determine the maximum height. Again, I'll put at the top of the category, the top of the section with word problems. Every single word problem, you have to complete the square or something like that. But as soon as you see this, maximum, minimum, then you need the vertex form, complete the square. And then this time it does ask us what the maximum height is and when it occurred. So again, we just want to make sure our statement reflects that we know what the answer is. So you do the same thing that we've been doing. The A value this time is -5. Bless you. Again, no C. Our life's a little bit simpler. This is going to be our B. Keep the -10 part. That's fine. Okay, so same thing. Factor the trinomial. -25 times -5 is +125. But you haven't answered yet, okay? So always in the back of your head, your little thought bubble, when you have these kinds of situations, don't push out of your brain things you already know. This value over here is the y, height. Time is x. Normally, oops. Normally time is the x, right? So then you have, it's a down parabola. We're looking for the maximum height and when it occurs, okay? So if it helps, write what the vertex is. So +5. You can even go back to like grade 9. If you have the first value here, what's this value? X, and this one's y. Time is x, h is y. That can help you too. Okay, so whatever is going to help you with this. Also, again, if you get this, can you have negative time? No, okay? So make sure you think about when you write your final sentence, think about, is my answer logical? Does it make sense? So it does ask us for maximum height and the time. It doesn't really matter which one you say first. It doesn't really say what the height is, so you could put whatever. Let's put meters. Usually we use time in seconds. Yes. Quickly. Philip. Okay, so the next two are about profit, okay? And these questions can be tricky because you have to write your own formula, but this year we're not going to. So, usually what you have to do is figure out how much whatever the person's starting costs are, like materials or whatever, and then there's this maximum profit for every time they increase the price. So you can't just charge whatever you feel like because then no one will buy stuff, right? So this is legitimate. You could definitely do this math. And so she sells, Sarah makes necklaces. She sells them for $10. Her sales average $20 per day. So she wants to increase the price. It says for every dollar increase, she would lose 2 sales per day. Okay? So we are trying to find what is the maximum profit, or sorry, what would the selling price be if if she wants to maximize the profits. So we'll use P. And X is, it doesn't really talk about like how many she's selling. It's saying she doesn't know how many times to increase the price. So the X is going to be the number of price increases. Sometimes it can be the number of units sold. That's even simpler. So you will be given something like this. Okay, so I'll give that to you, and then you just have to, again, we're doing the same thing. Complete the square, and then we're going to interpret our answer. So now we do have a C value, no problem. We just have to remember to collect like terms, okay? So you do the same thing, common factor the A value first. Again, when we get a final X value, it should be positive. We don't want to decrease the price. That's not what she's trying to do here. She's trying to make more money. So we have this last step here that we didn't have in the other two problems, okay? We didn't have to collect like terms, but here we do. But again, when we're done, it doesn't really help us answer the question. The maximum profit is $98. That's not what the question asks. It asks us to say what the selling price should be. So to maximize profits, how many $1 price increases should there be? What's the X value we can get from here? 3? So the pricing, all we've done is the number of price increases. She wants to increase it by every dollar, okay? Doesn't have to be $1. That's just what Sarah has picked. What was her original price? Good. And she wants to increase it by $1 3 times. So you could even write that like, I guess 3 times 1. So her price should be $13. You could even do it like 3 times. Increase it by 1, you'll get 13 as well, if that makes more sense to you. The next problem is similar, except it's $2 price increases, but it's essentially the same thing, and the numbers are not perfect. So sometimes in these word problems, you could have decimals, but they'll be nice decimals that don't repeat, okay? You won't have to round. And this one, I changed it to my name, but I forgot to change the pronoun. So if that bothers you, then just put Mr. Todd. Mr. Todd sells reusable straws to save the planet. Oh, there's a she. She charges $10 per straw, and he has been averaging 20 straws per week. He decides to increase the price, but he wants to increase it by $2. So then P is, P, we're going to use P for profit, and X will be the number of $2 price increases. Oh, sorry, X. Thank you. You can use whatever you want, but most people prefer X, okay? So the only reason why that really matters is, again, when we go to interpret our answer at the end, you have to make sure you're increasing the price based on the number of price increases by $2. So we have a C-value again, no big deal. We're going to common factor out this 2. And now we have 17, okay, which is a little bit ugly, but again, when you divide 17 by 2, you're going to get, even though it's 0.5, it's not a repeating decimal, so you don't have to worry too much about that, okay? Just use the decimal, square the decimal, and you won't have to round. Just keep the decimal places. It'll be fine. Still factor the first 3. Again, this number here becomes the factor, right? And because we have a C-value originally, we have to collect like terms. Since it's 8.5, that's a little bit weirder, but you could do the same thing, do the starting price plus $2 8.5 times, or you can just do the starting price plus 2 times the 8.5, the number of price increases. You just have to read through the stuff in the question and what was his starting price. $10. Good. And we're going to increase the price by $2 8.5 times. Okay, right? In an effort to not squish, I'm going to put more than one equal sign on a line. Don't tell Mr. Todd. Okay, so similar to the other section, the old textbook sucked, but this new one is fine. So on the back, there are these practice questions, and yes, there are answers there. but you don't need to do those. You can just do the questions from the textbook. And there's only a lot of them, or it looks like a lot of them, because you have to go, you're going to go back to those other problems and look for the minimize, maximize part, okay? So there's really not that many. 1, 2, 3, 4, 5, 6, 7. Okay, so not that many. You don't need to do these if you don't want to. You can just do the textbook questions.